Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad and Sallehudin, and today I will present about our group mini project, which is the title Design of a Grid Connected PV Power System for Residential Application, which is located in Brazil. For the introduction part, solar energy is a form of renewable energy that may be used to create electricity, heat and cool a home and illuminate commercial and residential structure. Since the beginning of the time, the sun has been the main source of energy on Earth. Solar energy is the sun radiation that the Earth absorbs. The most major potential, ecologically friendly alternative source of electricity in Brazil is the solar energy. Next, one of the renewable energy resources with the greatest rate of growth is the solar energy. Many countries have turned to solar energy as a less harmful option to produce electricity for fossil fuel or large-scale hydroelectric project due to concern about the environmental impact of this method. The potential for using solar energy in large-scale application has grown significantly in recent years, and the amount of solar energy that can reach the Earth can be utilized to generate power. Lastly, every indicator points to the continued widespread use of solar, thermal and photovoltaic technology in the near future. Next, for the design problem, in recent months, the media in Brazil have discussed and given more attention to solar energy. It's not a bad thing to regularly bring up the subject of the solar energy, but this does not imply that all of the problems that are related to it have been solved. It will briefly explain why Brazil, one of the sunniest countries in South and Latin America, has been able to make the crucial advancement in solar energy, and it will then list the several pressing issues that this country is currently dealing with. One of the challenges facing solar energy is the decision makers. Although the result for solar energy in terms of law and regulation are not as favorable as the verbal support, it is safe to say that almost every party supports solar energy to some extent. Lastly, the prominent example of this problem is the circumstance in Brazil. It has been discovered that the energy sector is particularly fragile in Brazil. On the other hand, it has had quick economic growth and industrial expansion, which have increased energy demand in lockstep. After that, the load profile, which is the load profile needed for construct a PV system. The residential load profile for no state Brazil Federal District Brazil must be determined in order to construct a PV system. As a result, some online research is conducted to determine what electrical items are often found in the home of no state Brazil Federal District Brazil. The most energy intensive equipment is 18 watt LED light, ceiling fans, air conditioning, refrigerator, washing machine and water heaters. Below figure and table show the residential daily load profile. Next, design a PV module. This project design calculation is divided into two components. The first step is to decide on the ideal PV solar system size that will provide the rooftop PV system with the most profit for Brazilian residential application. The second part of this challenge is the computation to determine the proper inverter sizing. This ensures that the investment cost is recouped within a reasonable period of time. If the design component parts are incompatible, it also saves money and energy during installation. There is a PV module in this design from Cheetah 72M watt solar panel. Supply the PV module using in this design, and smart string inverter provide the 35 kilowatt inverter, as shown from the two tables below. Calculation of PV solar panels, which is we use this equation to find the PV power system, and then ERQ, find the ERQ to find the energy required per year. Next is find the maximum power temperature. After find the temperature, find the derivative factor due to average maximum set, and then put all the result into the first equation, which is the PV power system equation. And then after find the power, we use the power to find the number of module of the PV panel. Next, the layout of the solar PV panel may be computed after inverter sizing. The number of modules in this series will be determined by the maximum output circuit voltage, which is the VOC max. After that, the open circuit voltage and number of modules in series, which is use the formula of the NS OC max. Next, the datasheet for the inverter has information on the maximum inverter input. The safety factor is 0.8, and the PV panel datasheet contains information on the string, short circuit, and then by using the formula, we find the string, which is 1.93. According to the datasheet for the 25 kilowatt smart screen inverter, it supports the 3 MPPT, each with 2 inputs. As a result, 1 stream per MPPT is equivalent to 6 streams. After determining the number of series and parallel, the optimal series parallel arrangement of PV panel is created and compared. The optimal inverter to PV panel ratio is between 0.9 and 0.1. The table 5 show the configuration of the series parallel solar. Then based on the table, 11 series and 6 parallel are selected. It is based on the ratio of the inverter power to PV power, which is 0.95. Furthermore, the house design in Brazil is mentioned. The PV model orientation is used to establish the optimal size on a rooftop, where the PV model arrangement is chosen from 2 possibilities that maximize the amount of panel placed. The roof of the home measure is 650.10 meter square. And then the installation of the solar panel at the rooftop. The total number of the solar panel that will be installed on the body rooftop is 9 to 4 modules by selecting the highest number for the series parallel configuration. According to the figure, the model layout is calculated by component and it will divide into 4 parts, which is A, B, C, D, E. And then the picture below shows the rooftop area and the solar panel area. From the table below, a maximum of the 462 units can be stacked horizontally and maximum of 462 units may be arranged vertically. Meanwhile, depending on the amount of modules required for home, only 20 modules are designed. As a result, the weight of PV array made up of 20 PV modules is 2 to 5 kg. Next, this is a diagram for the one line diagram of the PV system. Next, the return of investment, which is the ROI. The ROI was calculated. Before that, for one incident, a total of 20 photovoltaic model will be installed on the woody rooftop. The solar system energy output is calculated on weekly and annual basis by the below formula. And then the table shows the electrical tariff at Brazil. By using the electrical tariff, we find the annual cost service solar system at Brazilian Federal District Brazil, which is the result can be see on the table. And then 1 inverter with 6 streams per inverter and 11 panel 8 streams will be utilized in the solar system installation. The inverter number calculation is provided below. And then after that, the number of inverter needed is 20 divided by 66, and then we find the 1.3, which is for the 1 inverter. The installation project will be employ a total of 12 PV module and 1 inverter. ROI is measured by using the below formula, which is to find ROI. We put the installation cost divided by the annually cost saving, which is we find the ROI is 1 year 6 months. 1 year 9 months for the ROI. And then for the discussion, by compiling the country climatic data and load profile, the solar system installation on the body roof in northern Brazil, Federal District Brazil was made possible. The daily solar irradiation, average temperature, daily minimum temperature and daily maximum temperature for northern Brazil Federal District for the entire year 2021 are determined. The monthly temperature and sun irradiation are calculated using the data analysis as the same. And the PSH value is obtained by dividing the data by 1000 watt per meter square, which represent the solar power intensity for the equivalent number of hours in a day. Then for the conclusion, the design of the solar system in our Western Brazilian Federal District marks the conclusion of this mini project. Daily sun and irradiation, average temperature, daily lowest temperature and daily maximum temperature are all noted in the meteorological data. Home daily load profile is computed using an outage list to find and document the energy use of electrical appliances. The calculation show that the average PSA value is 194.05 and the annual energy consumption is 194.04 kWh. To calculate the reactive factor, which is the 0.825%, due to the average maximum set temperature for the 35 kW, to solar system, 30 solar panel modules and 1 inverter are needed. The vacant rooftop, solar panel area and where are accessed after constructing a PV power system to ensure that the system can be quickly built and placed on the rooftop without altering the building construction. The one-line graphic helps to clarify the layout of the PV system, and the object estimated return on investment ROI is computed and estimated to last 1 year and 9 months. That's all for me. Thank you.